Hello and welcome to the next stop in our feedback tour. So what we're going to be looking at this time around is different highlighting and things like that we can do with objects. So ways of drawing the player's attention to those objects and signaling that these are a thing that you can be interacting with. So let's dive on in. We've got our now familiar scene, and what I have set up here is a few different objects. So if we think about things that cue people in as stuff that can be interacted with, one of the key things is going to be movement. So that's the first thing we're going to actually set up for this, is we're going to set up a simple script that what it will do is it will make these objects move. So I'm going to set up a script here, and what I'm going to call this is just going to be let's call this object bouncer, and we will add this into our item prefab. So we'll make this that this has got object bouncer, which is good. And what we're then going to do is with that script, if we take a look, what we want to be able to do is we want to take that object and move it up and down, and also rotate it. So when we're moving stuff up and down, then we need to be controlling how far it's able to move. So that's something where first thing I want to set up here is the bounce amplitude. I'm going to say we don't want that to be too high, probably 0.25 is a good level. Then we want to control the rate that this is happening at. So what we want to be thinking of with this is what's going to be a set of units that makes the most sense. So for me, for something like this, I find that configuring something like the period for it is what makes the most sense. So how long it takes to do a full cycle, that I find makes a lot more sense to me for this. So I'm going to then set up my bounce period, and I want this to be a reasonable size. I don't want it to be bouncing super quickly, because we want it to draw attention but not be distracting. So that's good. We've got our amplitude, we've got our period for this, good. So I need to keep track of a couple of things. Well, if it's bouncing, that means I'm moving its location, which means I really need to keep track of its initial position. So initial position. So we will retrieve that. And in terms of where it's at with the bouncing, well, I need a progress variable. So we're going to have progress. And I don't want everything moving in perfect lockstep. I want things to be a little bit out of phase with each other. So I'm going to say that progress is equal to a random range between 0 and 1, just so they're all starting at a slightly different location. Then to work with this, well, progress, I need to add time.delta time divided by our bounce period. And with that added to it, I want to make sure it only goes between 0 and 1. So what I'm going to say is progress is equal to that updated value modulus 1. So it's going to update the progress and keep it bounded between 0 and 1. So that's good. We've got our initial position, we've got our progress. We need to now work out now where we move it to, because we've got our bounce amplitude, we've got our period and that progress, but how do we translate that? So this is where our trig functions like sine and cosine can come in really handy. So sine is going to be the one that I would go for in this case, from the point of view that sine starts off at 0, then over that cycle goes up, comes back down to 0, then goes down and back up to 0. So it's starting and ending at 0, which I think is going to work a little bit nicer for this. So what I would do is mathf sine. So I want my progress, and I would do progress by mathf.pi times 2. So our sine functions use radians, so we need to convert them. That won't necessarily be the same in other languages. Sometimes you might find ones that use degrees, but in this case it is specifically radians. So we want to be making sure we are providing a value that would correspond correctly. So that, if we multiply bounce amplitude by that, this gives us our height delta. So our height delta we've calculated. Calculate and apply the height delta. Because what we would then say is, okay, well, transform position, you are equal to my initial position plus, I could just use vector3.up multiplied by height delta. This should mean, with this, that our objects here are then bouncing up and down. So we've got this, let's test. We're expecting to see these moving, and they are. They're moving up and down, that's looking good. So as well as them bouncing up and down, I also want them to be rotating, because that will help draw a bit more attention to them, tends to look a little bit nicer as well. So again, I need to control the speed of rotation here. So I'm going to have the rotation speed, and so this will be in degrees, and I think we want to have this be something that it's not super rapid. So I'm going to go for 45. So, okay, what we would then do is apply the rotation. So we can go transform.rotate. Now this is in degrees, so we have our rotation speed by time.delta time. So that's good. We also want it to be rotated a random amount initially. So we'll say transform rotate 0, and we'll pick a random rotation between 0 and 360. So that way then it's just randomized a little bit where it's starting for each of them. Again, we're trying to avoid things being in perfect lockstep there, unless we wanted them to be, in which case we would remove those random calls from this. So now we've got these things that are bouncing up and down and moving, and it significantly draws more attention to them. They stand out a lot more. We would notice them quite easily because we've got that bit of motion that's there. And so this used to be one of the main ways to indicate that something was an interactable object. So that's good. We've got a bit of movement in there, which is great. What I want to now do is I actually want to get some highlighting happening in there. So I want to get these objects so that they're actually glowing a little bit and indicating, hey, here is something that you can interact with. So to do that, we're going to need to set up a shader. So I'm going to call this shader interactable object. And once I've created that shader, then I'm going to create a material based upon that interactable object. So we'll apply this to our prefab, and that will just make it nice and easy for us being able to configure this. So save that, so that's good. All of these have got our interactable object one on it, and it's just a default surface shader, so that's cool. So let's start updating this shader. Well, a couple of things that we want to have, and so certainly for testing, I want to have a highlight intensity. So highlight intensity, it's going to be a range from 0 to 1, and we'll start that at 0. We also want to have a highlight color, because the highlights we might want to have it be a very specific color, so that's good. So again, that's going to be a color, and we'll default that just to being a pure white. So then we can connect up our parameters here. So we've got our highlight intensity, and then we will also have our highlight color. So simplest version of this would just be to set the emission. So it would just be to go our emission, well, that's just our highlight color by highlight intensity. That's the simplest way of setting it up. It's not really going to give us exactly what we're after. And we need to fix up our typos. So used to adding in semicolons. So, okay, let's check that this is applying that highlighting. So we'll change the highlight color to sort of a yellowish, goldeny yellowish color is not uncommon. And we can see, as we ramp up that intensity, that's actually changing, which is good. What we want to do, though, is we want that highlight color and that intensity to actually be generated and changing over time. And we don't need to do that in C# code. Shaders have access to time information already. They can keep track of that. So we can be adjusting this dynamically in our shader. So what we would be doing is, well, we've got access to this time, which is a 4-dimensional vector. So it's a vector 4. So time, our x, y, z, and w components correspond to differently scaled versions of time. So x is time divided by 20, y is just time, z is time multiplied by 2, and w is time multiplied by 3. Now there are also sine and cosine time arrays. Those use different scalings there. So if you're switching and using a lot of different time ones, it's not necessarily a one-to-one. It's always best to just check, otherwise you can end up with really odd effects. So we want the y, and so I could be doing sine of time dot y and multiply that by a decent enough approximation for pi. So this would be our highlight intensity. But that doesn't give me any control over the period of this. So I actually want to be able to control the period. So I'm going to set up highlight period. Highlight period. That's going to be a float, and initially I don't want it to be cycling too quickly. So I think something like every 2 seconds, maybe every 1 second. Might actually go 1.5 initially, and then we can easily adjust it. So I do this, and I divide this by our highlight period, which we update our intensity. So divide that by the highlight period. So now we should have something that will just cycle. And if we run this, then we can see it's cycling. Now it's going fully black there. So we saw when we ran it had sections where it was getting really dark black, and that's because, remember, this is not giving us 0 to 1, this is giving us -1 to 1. So what we actually want to do is add 1 to this, so that we've got a 0 to 2 range, and then we just multiply it by 0.5. So it's getting scaled now to a 0 to 1 range. So it's just something to watch for, really easy to forget. And if we look at it now, then it's fading between its base color and going up to that new one, which is good. We can also, with this, we can set a maximum intensity. So we could have a highlight intensity, and this will actually control the maximum highlight intensity. That's going to be a range from 0 to 1, and we'll default it to 0.5. So how this is going to work is we need to actually, this gives us a 0 to 1 value. So I can then take our overall highlight intensity and multiply it. So this I'm going to rename to working intensity. So now we have a way of being able to rein that in. And we do just need to make sure we have, always easy to miss, so you have to set the variables up in a couple of spots. So this will just mean that we can give this an initial amount like 0.5. And then if we run this, so that's going to actually control, if we scale that right down, it's a much smaller amount of effect. If we scale it right up, so it gives us control over how strong that highlighting is proving to be. Now the other thing we could do is the highlighting, we could take on a little bit of our base color as well. So we could do C, red, green, blue, times by the highlight color, by the intensity. That'll take on a little bit of that base color then. So if I set this base color to something like a greenish color, and then run it. So it's going to keep a bit of that highlighting there. So it's still going to, that tinting is still going to have an effect. If I change that tint to a different color, it is going to change and impact the color that we see there. So it is still having an effect. It's just that it's building on top of the current colors that are already there, which works a little bit nicer. So that's good. We've got something where we are able to be adjusting how frequently it's highlighting, so how rapidly it's cycling between the different colors. And we've got that working, calculating the intensity, which is good. So now that we've got our objects highlighting, we've got ways of indicating, hey, this is a thing that you can interact with. What I now want to add in is for when these things go away. So being able to remove them. And one of the ways that we could do that is we could do a bit of a dissolve effect. And I've already got a texture here. It's a fairly simple texture, essentially just a bit of Perlin noise. And I want to use that to make this object able to dissolve. So let's look at how we go about setting this up. So what I would be doing to start with is I'm going to have a thing that's controlling the dissolve progress, which this is something we'll drive externally. So dissolve progress, that's going to go from 0 to 1, starting at 0. We'll also have our dissolve texture. So dissolve texture, that's going to be just a plain white texture to begin with. And so then I can set up down here, I'm going to have my dissolve progress, and for my texture, I'm going to need a Amplitude dissolve texture. So that's good. So we've got those parameters set up. With those set up, I will link up the texture in the material. So we'll grab our dissolve texture. And what I want to have happen is as we fade in, it actually then essentially culls out chunks of the object, which what I can do is my progress goes from 0 to 1. My texture is going from 0 to 1 effectively, because it's a grayscale texture. So what I could be doing is as this value goes up, that kind of sets the watermark in the texture, and anything below that gets culled out based on, we can look at the UV coordinates. So what I could be doing is here we're going to update the emission. So update the, we'll calculate the highlight intensity and apply the highlight. So what I want to do is firstly sample my dissolve texture. So sample the dissolve texture, and then that is going to dissolve threshold is text2d, dissolve texture. We can use exact same UV coordinates. So now we've got that sampled value that's between 0 and 1. And then, so for determining whether or not it fades out a chunk, there's a function called clip. So what clip does is it allows us to say, essentially, don't render this pixel. So what you do is, when you provide a value into clip f, that value is below 0, it won't render it. So I could say, okay, well, clip, and I can do this above here. So, okay, threshold, anything that's below that shouldn't get rendered at this point, if it's based on our progress. So I could do something where, if I just did dissolve threshold, for example, nothing's going to actually render at that point. But if I do dissolve threshold minus the dissolve progress, what that is going to mean is as our progress goes up, this value is going to get pulled further and further and further down till it reaches a point where it's entirely below 0 and everything should get clipped. So let's test. So we ramp up our progress. You can see we get holes appearing in this and they're disappearing. So that's cool. We have it being able to disappear. What would be kind of nice is if there was a bit of a boundary there where it was highlighting and making that boundary nice and intense. So what I could have is dissolve boundary color or edge color. Dissolve edge color. Dissolve edge color. And that's just going to be a color, which will make that initially just white. And then I also want the dissolve edge depth. Dissolve edge depth. This is going to be a range from 0 to 1 and will initially be equal to 0. So we'll be able to link up these colors and everything. So we'll have a fixed 4 for our edge color, and we have our edge depth, which is just going to be a half. So, okay, anything that is up to dissolve progress is going to get culled. Anything that's between dissolve progress and our edge is going to be this highlighted color. So what I want to do is, initially I'm going to write this just with an if statement. So f are, and actually we could put this in a separate parameter. So half dissolve factor. So clip f below 0. So we could be then checking if dissolve factor, if it is below that edge. So if dissolve factor is less than our edge depth, then what we want to do is we want to apply a bit of a tint, and we might apply this tint in a couple of ways, but if we actually tint the albedo, that's going to work quite nicely. So I might actually change this down here to be the albedo, and I'm going to say that our albedo, we lerp from whatever it currently is to our edge color based upon this factor relative, where it is relative to our edge depth. So we can actually say, well, actually no, in this case, if it's less than that, we just want it to be our edge color. We don't need to do any blending yet. So we can just do that. So let's take a look and see how this works. So it should largely look the same initially, where we get it fading in like that. But what I want to be able to do is if I increase this depth, you can see we get those edges of it being highlighted, which means we could change this to be something like a bright sort of reddish color, so that it looks a little bit like it's actually on fire. And the depth of the edge there is going to determine how sort of thick that is. And so we'll see that fades in, and that looks quite nice. That ends up looking really sort of good with that effect. Now, I did this using an if statement. I want to be able to do this without using an if statement. So this is where I can use the step function. So the way step works is you provide it with an edge value and then a value to test against that edge. If it is below, so A is our edge, so in this case I'm going to say the edge is dissolve edge depth, and then we use dissolve factor. So if dissolve factor is below that edge depth, the value we get back from this will be 0. If it is above it, we get 1. So this is a bit of a faster way than doing a if statement with this. So what I could say is O.albedo equal to, and I'm going to do a loop. So remember, 0 means it's dissolving. So 0, we'll use dissolve edge color. And then we have albedo like that. So this should give us the same result, but it's going to give us the same result more efficiently. And we can see we ramp that up. So that looks pretty good. So apply, or calculate, highlight the edge region. So this is equivalent to the line above. It's just that the if statement version is a slower version of doing it, but it's still equivalent to it. So, okay, we've got a nice cool edge showing there. So what we want is we want it to be that dissolving is controlled externally. So we want to have a little bit of a script on the object, and we're going to call this the object dissolver. And what the object dissolver will do is it will actually talk to the shader and set that dissolve progress. So it's going to have bool is dissolving. So that'll be a way that we can kick it off. It's going to have control for the time. Dissolve time. So we might say that it takes place over 2 seconds. We could also have a curve if we wanted to control the pacing of that. I don't think for something like this we really need to. But that will sit on the particular object. We're going to then have this link to the particular mesh. So it's going to need to, actually we'll discover those dynamically. So what we're going to have on our prefab, if we grab this, then this is going to have our object dissolver script. And what we will do is keep track of our progress. Dissolve progress is going to be 0. So in update, well, f is dissolving, then our progress gets updated. So plus equals time.delta time divided by dissolve time. So we update our progress, update the progress. We want to check if we're finished. So f the dissolve progress is greater than or equal to 1, then just destroy this game object. Otherwise, we're going to need to update the visuals. So to update the visuals, we need to be able to set data on the materials. So we need to actually find all of the mesh renderers within this. And in particular, we're looking for mesh renderers that are going to have the shader supports being able to do the dissolving. So what we can do is we can do a get components in children for mesh renderer. And we can then say that we have our list of ones here. So mesh renderers, mesh renderers. And we'll store that. So we retrieve all of those. Retrieve all of the renderers. Then what we need to do is we want to initially make sure this is properly set. So I'm going to go through and every one of these renderers, so index is less than mesh renderers. And I'm using the conventional style for loop just because there's a lot of things that we would potentially be doing this on. So if it's going to be running a lot of times, any little bit of saving is worth it. So I want to set up a material property block. So prop block, new material property block, and then what I will do is prop block set float, and we can check here what we're wanting to set is our dissolve progress. So we get our dissolve progress, and we set that initially to 0. So now that we've configured the property block, what we want to do is we want to grab that mesh renderer and then set property block, and we give it prop block. So that will have all of them properly started at 0, which is good. And we can actually, because they're all using the exact same one, we can get away with doing this, which is good. So now what we want to do then is, in this property block, we don't need to be recreating it every single time. So we're going to set up just a variable up here so that we are not continually allocating that. So start the dissolve progress at 0. This makes it then a lot easier for what we do down here is we just update this, and this updates the dissolve progress. What this should mean is that on then any of these items, when we go and run it, they'll start out, they're not dissolving, anything like of that. We can see them fully. And then if I click is dissolving, see that it fades away, and then it destroys. And on each one of these, as that happens, so they're working independently and they're just cleaning up after they're done. So now we've got objects that are moving, objects that are highlighting, objects that for when we're finished with them, they're able to dissolve and fade away really nicely, which is great. We've got a bunch of things there for being able to indicate and highlight what's happening with these objects. So now that we've got our different effects going, the final thing I want to do is just enhance the dissolve effect a little bit, because with the dissolve, if we extend this a little bit, those edges, I'd kind of really like those to be brighter. So what I'm going to do is, if that dissolve is happening, I actually want to adjust the emission there. So again, this is something where, okay, we have, during that edge, we want to change what it's actually doing. So I'm going to say that here, we're going to lerp between our dissolve edge color and our tinted one based upon, again, we can reuse this. And so that way then, that highlight is also tied to this. And what that will do, as we can see, is that makes that highlight a lot brighter. So those edges really stand out. So it still highlights as normal, but those edges are very, very bright, which is great. Like, that's what we want, is something where from a distance we can see those much clearer, that it's actually progressing. So that looks pretty good, and we can test if we run that, just seeing how that looks. So we enable that, so it stands out nice and clearly, and it makes it have that a bit more of that sort of fiery burning effect that we've got there. And we could use, you know, whatever tint colors we want, we can be using there with it, and that's separated from a highlight color, so it works out really nicely with it. So just to recap the key things that we've got, we are looking at different ways of how we can provide feedback to the player in terms of things, and in particular feedback in regards to objects. So we have our script that's able to bounce an object, and what we set up was just some simple controls for position, for the period and everything for it, and its rotation speed. One of the key things we did was we just randomized stuff like the progress and the rotation initially so that they didn't move in lockstep. That just tends to work out a little bit nicer with it. We also then set up our dissolve effect. So this has a little bit of script side logic. So to actually find the mesh renderers, to pass through the progress there for that. And most of the logic sits in the shader. And it's not really much more than just a standard surface shader. We're not adding in much beyond that. What we have is, for highlighting it, we're adjusting the emission. And what we were doing is we were taking our albedo color, so the color that it would normally be using for that location. We are then applying a highlight color with a bit of the intensity there as well, just to actually adjust what that's looking like. And that works out quite nicely. So, okay, we've got our emission being set there, and then we wanted to have a bit of a dissolve effect. So what we do is we have a noise texture, which in our case we're just using very simple sort of Perlin noise style texture, and then we sample that, and that texture gives us our threshold. And as our progress goes up, values on the object where that texture is coming back and saying it's below that threshold, those get culled, which we cull them by using this clip function. So anything below 0, it just won't render it. And then we wanted to make it that we can have a bit of a highlighting there, so we had a little bit of an edge depth. And to make it efficient, we didn't want to use an if statement, so we used the step function with a lerp. Really common thing that you'll see there, because step always returns 0 or 1, so it means lerp with a step allows you to do, well, if you know, this scenario, give this value, otherwise give this other value. So it gives you a way of doing that. And that created our really nice set of edges that we had for this, which gave us a really cool effect. Thanks folks, I hope you found the video helpful. If you're looking for the code for the project, that's available up on the GitHub, and the link to that is in the description below. If you have found the video helpful, please do chuck in a like and subscribe, it really does help out. And if you've got questions, chuck in a comment below. If you're wanting to submit those questions instead for the next Q&A video, then you'll see in the description there's a link to a Google form. You can submit your questions via that as well. And if you're looking for other ways to support the channel, I do have a Patreon, and the link to that's in the description below. Bye!